Okay, this is a amplifier I picked up at the boot fair a couple of weeks ago actually. It was sold, believe it or not, most people are quite genuine at boot fairs, and this, I asked the seller, does it work? He said no. He said he tried it quickly, it's been in his loft for a while, he said it doesn't work, and I could have it for 10 quid, so I was, okay, so I snapped it up for 10 quid. So I brought it back into the workshop and just given it a try, and indeed it is absolutely dead. It does all the things it should do, apart from this is a couple of LEDs bulbs behind here that should light up with this new Class A and computer drive. This is all a Technics new Class A system. The idea was basically it's a dynamic bias adjustment for the amplifier. It adjusts the bias according to the signal level. Totally unnecessary, but got lots of nice lights on it here with quiescent current control and state of the signal and bias. It's all just mumbo jumbo, really. Not totally unnecessary, but these are nice amplifiers. I quite like these. This is the SU-V303. The workshop's amplifier I've got is also the SU version, but it's SU-V505, which is the higher power version. I think about 60 watts, 50 watts RMS per channel. This is rated at 40 watts. And Hi-Fi Choice actually gave this quite a reasonable review when it came out. It came out, I think, about in 1983, something like that, and it was selling for about £129. And I always like the look of them. I think they're a lovely looking amplifier. I love these controls, I love the aluminium, and I particularly like the black fascia type amplifiers. So the thing to do is try and trace down what the hell is wrong with this amplifier. It's unusual because it will turn on and it will release the protection circuitry, but there's absolutely no audio passing through it. Now, from memory, I think these amplifiers use a couple of hybrid ICs or ASICs, for want of a better word, you know, for the computer controlled system and also part of the preamplifier. I haven't actually got the 303, the 303's service manual here, but we're just going to power it up and let me just show you. I'm feeding in audio to the CD input from my phone, and there's nothing on any speaker setting. Let's say that it's come back now. I've got one channel working. Okay, so that's probably a noisy switch, but certainly on the pops are very jumpy. Amplifier seems very underpowered actually. Okay, so that's the left hand channel actually that's working. But there's nothing at all. Clearly the balance control is very noisy, but I don't think that's a problem. There's no hiss or anything on the other channels. So let's get the cover off this, have a quick look inside, and see if we can see any sort of signs of burning or anything dislodged or any connectors, because there's a lot of sort of ribbon cables used in this for transferring audio and stuff, so there's possibly one of those, just a bad joint or something. So let's have a look inside. Well, apart from a load of dust inside, there's I can't see anything obviously wrong. Quite traditionally laid out, all these sort of stereo amplifiers were. Preamplifier stage is probably down here is probably the phono amplifier. This is where the audio is all controlled by this computer drive, mumbo jumbo. Tone control stuff down here. There's another board here. I don't know what this is. It looks like a preamplifier of some description. Biasing control. You do have some control over the bias on these. It goes into the main power amplifier stage. Now, what I could do is do a bit of tracing with the scope, I suppose, and have a look around the left and right channels and see if we can work out where the signal's lost. As I say, it's got this strange Technics chip in here, computer drive chip, and a couple of other chips that look like a Technics own sort of as I say, ASIC sort of thing. Now, if that's the case, if that's failed, it's probably written this off. I did have one of these, unfortunately. I think I threw all the parts away from it, but I don't think I saved any of the chips out of the machine, out of the unit. So let's go through, check a few sort of obvious things. I'll go through with the scope, and if I find anything, it's going to be a bit of a case of poking around with the scope to try and work out where the signal's getting lost, and if I find anything, I'll show you on the video. We're looking down here on the very early stages of the preamplifier, before the preamplifier really, before it looks like where the signal comes in. We've got these two resistors here. Let me try and find the best place for you to see it. There, these two resistors, you see these two? Look at the scope. That's one channel, and this is the other channel. Nothing. So there's no signal getting even in as this early stage. So that suggests to me that there's a problem with the switch, or possibly even a fractured board maybe. I've just downloaded the circuit diagram or the schematic so we can try and work out what it is. I've just checked to see if there's any DC on that supply, and there isn't. So you can use a quick and easy way of buzzing it out just to see if it works. If you touch the end of a screwdriver on an audio amplifier, you have to make sure there's no voltage on it. You have to be very careful what you're doing. And bear in mind I am running on an isolation transformer. So I'm going to buzz this connection. Can you hear that? Let me just turn the volume up a bit. Okay, that's the channel that's working, and that's the other channel now. So clearly the amplifier's working, but there's a break in connection to the feed of the possibly the feed of the very front end of the amplifier. So I think what I'm going to do is have a quick look at our 201 and 202 in the manual, which are those two resistors there, and see if I can ascertain whereabouts that is in the circuit. I've got the bottom of the unit off. These are the two resistors. Here's the right channel and the left channel. They're buzzing out okay, and they're fed to this point here. It takes you across these links, these wire links at the top. You see these purple and pink and white leads that go to the past the switch and come out just here. So we've got audio to that point, and from there then we lose it all. Now that's all part of the switch mechanism, so we need to track that through and try and work out where the signal's being lost. So yeah, that next thing to do, we'll put a continuity check back to the switch, check the switch is working. Might actually have some of those spare switches if the switch is a problem. They don't usually fail. They become noisy, but they don't usually fail totally. I'm still expecting to find a cracked board or something like that. So do a couple of continuity checks and I'll see what you find. Well, I've got the right at the back of the amplifier off, and I've got intermittent connection now, and every now and then I get the sound through. So I think what it is, all it was it probably is just a noisy switch. These gangs here do one channel, and these gangs do another channel. So if there's more crud in this side of the switch, basically that whole switch will stop working. Usually, or what I usually expect to see, is that will be the left channel, that gang there, and that will be the right. So if crud's got into that, it will affect both the channels a similar amount. But that's what happens when you assume what the fault is. So this looks like it's going to be a fairly straightforward fault. This is the channel that's messing around. If I mess about the selector switch, you can hear every now and then. It's pretty crap, but it works. You can buzz it. So basically what this is doing is one of these, probably the center connection goes to the feed to the preamplifier, and it selects which input it wants, either the outer one here or the other one. So basically this is basically the changeover selection for the input selector. So what I'm going to do, I think I'll do is I'll reflow the joints, and then I'll give it some contact cleaner, and let's see if that puts the thing straight. Okay, I don't know if you can hear there, but we've got stereo again, so That's all it was. Noisy switch, very dirty switch obviously, and the unit was very dusty. So I'm going to put the bottom on, put the back panel back on, clean all the pots and switches up, and then I investigate the bulbs that have failed in there, but that's not the end of the world. I'm not that bothered if they light up or not, but amplifier sounds like it's good. Right, it's back together again. It's working on both channels, but unfortunately when I was working on it I had to take the front panel off to clean up some of the switches, and I've managed to break the bloody track that connects this is the speaker switch, connects to the front panel, and it's connected through like a I want for a better word, it's like a conveyor belt. It's like I'll show you what it is. It's one of these belts, and basically that clips into the switch, so it allows you to have a switch remotely mounted from the front panel that plugs into there. But the track at the end obviously got work hardened and snapped. You see at the end it's just snapped off, got twisted and snapped. So anyone got one of these? It basically makes the front panel bloody useless. The speaker switch doesn't work anymore. So I've obviously pushed the switch over to the right position to make it work, but the amplifier works well, it sounds nice. So not a total success. Obviously I've got the amplifier working, but now I've got no speaker selector switch. So I'll put the top back on it, and maybe I'll do a power measurement on it, see how much power it can produce. Now running into the audio analyzer, 1 kHz just before clipping. I'm getting 45 watts RMS out of it. It's not bad. Both channels driven to 8 ohms. Distortion level is at that level of drive 0.01%, which is pretty good. So it's a pretty respectable sort of output. We could do a oh, it's back again. What's happened there? We could do a frequency response check, I suppose, just to see what it's like. So let's turn the drive level down. Let's set our reference points. The level's shifting around a bit. There's a dirty switch or something. Moving the speaker switch around trying to get a better connection. Trouble is I don't know where the correct position of that speaker switch is anymore now that track's broken. It's gone open. Try and find a slightly noisy volume control. Like a low frequency oscillation on it maybe. I'm not sure I've got this set up right, actually, because I think this audio analyzer are actually running on this isolation transform. I think that's probably a bad idea. I think it causes all sorts of strange effects because I'm using there's an offset between the if there's a slight phase shift between the mains frequency, I think you get like a beating effect. I'm not sure if that's what it is, but I'm getting sort of like strange results. I don't get that if I feed the audio straight into the audio analyzer. I don't get this low frequency sort of moving about all the time. Let's put a subsonic filter on, see what that does. Okay, so there's something weird there. So let's try and investigate what's going on with that, and I'll have another go. Well, let's finish this amplifier off by doing a quick frequency response check and distortion, things like that, just to see how it's performing. The cover's off. One of my viewers pointed out that with the cover off it's going to pick up noise and things. Yeah, that is true. I've turned the LED light off above me and it should be fairly quiet, so I'm just going to drive the amplifier just into clipping, which is about there. Give me a bit of time base so you can see what's happening. Okay, we're looking at a distortion factor of, what is this, 0.01%, which is pretty good. So let's measure our power. So we'll go to, that's at 20 kilohertz by the way. Let's go to a more simple frequency, 0.03%. okay, let's check we're not clipping. Pretty close on clipping actually. Let's just turn the power down slightly. Yeah, 0.03%. So that's pretty good. So let's do a frequency response check. So we'll, there's our it's AC level 0 dB. I'm going to sweep from 20 Hz to 20 kilohertz to see what we get. Looking pretty flat. Both channels driven this is. So about a 1 dB roll off at 20 kilohertz. It's perfectly adequate. Let's just measure our peak power before clipping. So we need 19.08 special. Just drive it up to clipping. You're looking for flat topping on the waveform. Just started there. Just off clipping. See the jittery edges where the power supply just run out of it. Hasn't got enough volts to drive the transistors any further. That doesn't look like power to me. So let's do that again. 19.08 special. Man, ain't bloody night. What's going on here? Right, do a system reset, 41.0 special. Okay, it's a reset. Frequency 1 kilohertz, amplitude 500 millivolts, 19.08 special. There we go. Let's look a bit more like it. Let's go back to the waveform. So we're just clipping now, and it's showing 36 watts, which is less than I was expecting actually. Now the amplifier is getting quite warm now, so I'm wondering if it's backing itself off. Just do a check again. AC level 16 volts. Yeah, it's only actually producing 16 volts now. So that's 16.24. What this calculation is doing with the special function is when I type 19.08, it's taking 16.2 and 3 and squaring it and dividing it by 8. 19.08 tells the analyzer to want to measure power, and then the 0.8 specifies the load. So if I point 19.04, it would be into a 4 ohm load, so it can calculate the yeah, I'm only getting 30 watts now. That's interesting. I don't know if the amplifier is getting hot and slugging itself back to prevent sort of thermal runaway, but it's only making 33 watts now. So, but the amplifier seems to work perfectly well. I'll recheck that power level again later on, but it's a shame about the speaker switch. I'll maybe try and find another one of those, but we shall go from here.